My name is Lavi. I'm the CEO and co-founder of Ride Vision. Ride Vision develops collision avoidance technology for motorcycles. Needless to say, motorcycles are the most vulnerable vehicles on the roads. About 700 million units available across the globe, and about 70 million are being manufactured every year. Yet, almost 400,000 fatalities a year are credited due to motorcycle accidents. And of course, if you look at the statistical data on per country basis, you find something like 28 times more chances to die in a motorcycle accident than a car occupant. Now, on the EU level, only in 2015, we had almost 5,000 fatalities that resulted in almost 4.1% GDP loss for some EU countries. These are staggering numbers, and they will just continue to grow because of the urbanization and global congestions on the roads. But even with the COVID-19, people still prefer personal mobility, such as motorcycles, scooters, and even electrical bicycles, rather than a public transportation. Now, when you analyze the crash data, you see that only less than 3% are due to oil spills and cracks and etc. on the roads. The majority of the accidents are through collisions. These collisions are mainly coming from the frontal area, and they are majorly built out of the motorbike via a vehicle collision. So they're mainly coming from the frontal area. There's some coming from the rear area, but in total we're talking about 76% of total accidents between a motorbike and a car. Now this is a huge gap that is not being addressed. And the reason why Ride Vision brings an ADAS solution, a unique ADAS solution for motorcycles, and it's so different from cars, is because if you really think about what you need to solve, it's essentially different from what we know from the cars. And what we really need to solve here is both in terms of the psychology of the riding, which is different, the HMI, which is completely different. There's no enough space to put alerts, what kind of alerts, and etc. And finally, there's a huge difference between a vehicle or vehicle types. And we'll talk about that in the next two slides. But just to give you a quick example, as a driver, you have a very good vision of what's going around you. But honestly, we're a bit distracted as drivers, right? We sometimes listen to music, play with our mobile phones, unfortunately. And then we need to have a huge stimulus, a pretty intense alert in terms of the potential collision avoidance in order to react if we're talking about warning systems. Now, as a biker, we can't deliver any intense alerts. An intense alert, in our case, will just create the opposite solution and will actually let us collide than prevent accidents. In addition, we can't talk easily about emergency brake systems or things like that. We really need to talk about a combination here of something. And even on the warning level, like systems that only deliver warning, we still need to deliver pretty simple and intuitive alerts in order to allow the rider to break the focus. What do I mean by that? As a rider, we fixate on specific objects, and we have like object fixation issue. And we fixate on a specific car that we feel poses a danger, but actually, in reality, a completely different car will be posing a danger, and that will create a collision. So we need to deliver alerts in a way that will allow us to shift our focus. On the vehicle level, there are tons of challenges. Because if you really think about that, it's a very lightweight vehicle that vibrates all the time. It goes up and down, up and down. And we can move our handlebar to the left and to the right, and mostly we lean to the left and to the right. So there's lots of changes that happen in that vehicle that really impose challenges to any sensor that is being installed on the vehicle. Now, in addition, the maneuverability of that vehicle is very, very unique. It's very dynamic, very fast, and in some countries, so even in the majorities, if it's not even been stated, sometimes motorcycles are coming very close to cars or zigzag between the cars by lane splitting the same lane, and etc. etc. So if you really think about that, then there's a huge question: where does the bike go? What is the predictive path, and etc. And finally, we don't have enough place, no energy to put the sensors, so let's say even a big set or array of sensors. So we really need to figure out, on one hand, a simplistic or apply a simplistic approach in terms of the sensors, but very, very complex approach in terms of the software. And that's exactly what Right Vision does. So we deliver two wide-angle cameras, front camera and rear camera. And those two wide-angle cameras allow us in the movement of the bike to analyze almost 360 degrees around the bike. Now, by taking that feed and analyzing that feed, and then understanding what is the predictive path of a motorbike, that we can then generate alerts to the rider. Now, Right Vision spend a lots of money and energy in analyzing what are the best alerts that are going to be delivered to the riders. And what we have found is that the visual warnings are the most effective one. So we actually mimic some of the language, the visual language that is being taken from the cars, like the blind spots. And we're basically utilizing LED strips, whether within the mirrors, on top of the mirrors, if that's an aftermarket product, by very elegantly, very simply notify the riders where the danger comes from and what kind of danger, and then we allow them to respond to the actual alert. Now, if needed, we can escalate those alerts via audio to the helmet of the biker, but I have to tell you that after an extensive research, the less we escalate and the more we maintain a simple, simplistic visual language, the better it is, because then it allows the biker to concentrate on the road and continue to be focused. Now, this is our aftermarket product. Those are the wide-angle cameras I mentioned before. That's the front camera, that's the rear camera. Those are the LED extensions that we put on top of the mirrors. That this will be blind spot warnings and dangerous overtakes. That will be the frontal area, which means forward collision, distance keeping, headway monitoring, forward left collision or forward right collision, depending on the mirror. And then that's a brain unit that sits or is being located under the seat of the biker. So that's the aftermarket product. And just to show you how that looks like in terms of the execution, let me share with you a video that demonstrates the alerts. Here we have a system that is been a bit more integrated into the bike. We have here integrated mirrors. You can see the HMI, you can see the blind spots, you can see the frontal area. And as we ride, you can pay attention that the bike vibrates, goes up and down, it tilts, it goes left and right, leans and etc. So all those unique transformations we mentioned before. Now, when we start riding, you can see a left blind spot warning here that is being alerted on a car that passes on the left side. But already here we have a huge difference, because here we have a bike that leans at 16 degrees, 1/6, and this is a very small degree. A bike could go easily to 20, 30, 40 degrees at the roundabout for sure. And in that sense, what happens here, there are some sensors that already at this very small degree will not operate correctly, such as radar, for example. But what will happen here is that the car will be joining on the outer lane of a roundabout. And as you know, with the motorbikes, we really need to move our head to see what's going on. In that case, this bright blind spot warning eliminates the need to move our head as the car comes in, because then we know that the car comes in. If we need to merge to the right lane, we're not going to do it. We're going to avoid moving our heads and losing our frontal focus. In this case, we have a continuous blind spot warning, so as long as the car maintains that blind spot area, we'll continue to alert. Some cars will have it, some will not. Pay attention on the vibrations that are happening here. And next use case is a totally very unique use case to Right Vision, and it's called dangerous overtakes. And what happens, as I explained with the movements of the heads, the movements of the heads on a bike are crucial operations. So if we need to join our left lane, we need to move our head, and let's assume at 100 kilometers an hour that we're doing that operation. 100 kilometers an hour, half a second of movement of our head, it's about 15 meters of progression of a bike, in which we're actually losing the control, losing our focus from the frontal area. So if there is a car coming from behind of the bike and overtakes the bike very, very harshly, very quickly accelerates against the bike, then moving our head is not enough. Sometimes we're moving our head and then we're turning our head to the frontal area, and then only then the car comes into that blind area and basically creates a potential crash, because then we start already lean and merge into the left lane. So what we're doing is predictively analyze this particular scenario, and we can alert up to 25 meters back. And the way how we can demonstrate it here, we create a gap and then the car accelerates, and you see that there is about 3 seconds that this dangerous overtake alert is on, and with that relative speed, we were talking about 14 meters back. Now, this is a distance keeping violation. This is 0.5 seconds until the next vehicle. Of course, configurable. You can see that despite of the vibrations, leaning, etc., that will stay on as reddish alert that will tell us that we are too close. We need to either brake, or we need to lean to the left or lean to the right, actually take, actually moving to the left and to the right, or the car will accelerate, as we will see here in a second, to about 0.7, and then the alert will go off. And of course, the last alert that I want to demonstrate here is, of course, the most crucial alert, which is the forward collision. Maybe it will be hard to see as we capture the screen, but we accelerate and it blinks harshly. We either need to brake or we need to move to the left or to the right. Basically, that is one of the interesting outcomes of the motorbikes. We don't need to fully brake. We can go ahead and lean to the left, lean to the right, and run away. It's crucial. So if we come back, I think that explains, that delivers the experience. Of course, the system acts as a dash cam. We capture the footage from both cameras. But of course, we're talking about preventing accidents with this system, with the Right Vision system. And interestingly enough, there is an academic research that shows that if you reduce 10 kilometers an hour prior to an accident, prior to a potential collision, regardless of your self-speed, on a two-wheeler, on a power two-wheeler motorbike, you can reduce up to 25% of your frontal collisions. Now, the reason to that is because we're a small object, we can lean away, we can run away, it's easy for us to do that stuff. There is another research coming from the trucks on the warning-only systems that have been installed for frontal collision, and they show 27% reduction of frontal collisions. Now, interestingly enough, we can see from Right Vision's data that has been captured on tens of thousands of kilometers of ride that based on our alerts, our frontal alerts, we see that the bikers reduce their average speed by 15 kilometers an hour, which is very correlative to what we have seen here and here. And in addition, if you add to that the blind spots and the dangerous overtakes and the reason to what happens to us when we move our heads, then the system is expected to operate with up to 40% reduction in terms of the collision. So it's a very, very promising research and data that we capture. And of course, finally, in order to summarize, in order to really succeed with that, we need to build the right system, and that will ensure the adoption, because we need to build it in the mindset of bikers. And of course, if we do that, we also will have good participants and a good ecosystem. So for example, Right Vision already have an insurance company that works with Right Vision in Italy that delivers basically retrofitted discounts to anybody who installs Right Vision as a retrofit. And of course, regulating such system is important, because definitely there is a huge gap, there is a big issue, as we have seen, and it's important to succeed and bring the innovation to the market. Thank you very much. If you have any questions, you're welcome to post an email or send an email to me directly. I'll be happy to answer. Thank you again for your time. Appreciate for the invite.